working as you expect. Because I'm sure there's been moments when, if you haven't written test, you've written something and gone, huh, it worked first time. How does this happen? When would you write the unit tests? Well, I'm pretty sure you've heard talks about TDD, where you'd write tests at the very start before you'd even written any code, which is fine. I'm more of a write code and then write the test just to verify that my code is fine. Or you can go the extreme approach and write all the tests after you've released something to production, and then realize that, shit, that's not what it's supposed to do. So who is going to be doing all this testing? That is you, all the developers here. Because you're writing the code, you'll be writing the unit tests as well. But everybody could get involved in just making sure that all the stuff that you're testing is relevant, and not just this private thing is called as private service. But there are times when you are advocating for unit testing and people aren't really on board. They'll just say, oh, I'm just wasting my time here. What is the value of these tests? I'm just wasting time where I could be delivering stuff far more quickly. And there are some cases where there are commercial agreements where you've got a short deadline and something has to give. So testing is often the thing that just takes the back seat. So you just have to go with it. So like I mentioned, if you're not doing testing, you've obviously got enhanced productivity because you're delivering a load more stuff. You're almost like Superman or Superwoman, just getting stuff done. You're the golden person on the team, just pushing out PRs, everything's all fine. But then you have this thing called the prisoner's dilemma, which I guess isn't really about coding, but I've sort of made it about coding, just shoot one in there, where imagine you've got two developers or two teams of developers. You've got one person or one team that is just delivering a load of stuff. They're getting praised, maybe they're even getting bonuses. And then you've got another team which is delivering some high quality stuff, but it takes time because they're writing unit tests to make sure that everything is working as they expect. So oftentimes the other team that's writing good quality software will be like, well, I'm not really getting much reward for this. What is the point? So I'll just revert to, or just write the code. But that isn't really what you want. Because when that happens, well, the obvious happens. You release a load of stuff, and oh, this is fine. There's one or two little bugs that have crept in, until like a load of stuff goes wrong, and then you just say, oh, I knew this had happened. So, why am I giving this talk? So imagine you've just started a new job, or you've moved position in your current job, and you're put on a glorious brownfield project, and you're a bit curious. You say, this code base is quite big. Does it have any tests? And the response you get back is, yeah, sure we have some tests. And then you search for the test, and this is the test you find. This is when it would be good to have audio in the slides, because you're like, right. So yeah, that's not really testing anything, because you could be running it through your CI pipeline going, oh, well, the test pass. Everything's all working fine. You release it. Oh, this little thing's not working. Oh, it's not working. Let's try and fix that. Until eventually Armageddon, and everything's just kind of messed up, and you advocate for a rewrite then. So, like I said, most of it's going to be code related. So I hope you're ready, because I am ready. So the tool we are going to be using today is Jest. Other frameworks are available. I'm quite keen on using Mocha as well, but Jest just they're pretty much the same kind of API underneath. So let's get going. So we have our magical sorting hat, and we have our sorting hat v0, which is just setting everything up. So here we have our class of a sorting hat. We have a few functions here. We've got a public one where we're placing the hat on the head of a student, and we have a private thing which we're going to be going into in a minute. So here's just the student, which is just a name and some characteristics of that student, and that's some of the houses, which any Harry Potter fans will know these houses. So here is a simple test with Jest. This is all the setup. So we've got this is just a thing that I tend to do when I'm writing tests. I'll do before each just to set a new instance of the thing I'm testing, often called the subject. And I've got a list of things that I want to be able to test that work. So for V1, we're going to be doing some implementation. So here we have implemented our pick house, where we're checking the characteristics and then putting them in the right house that suits that characteristic. So we've got Harry Potter in Gryffindor, we've got Hermione in Hufflepuff, Luna Lovegood in Ravenclaw, and Draco in Slytherin. And it all seems to work just fine. And then we've obviously got the evil John Smith, who can't be put into any house at all. So yeah, piece of cake really, piece of cake. So V2. There are times when you're writing tests for things that don't just have a return value. You might be looking at a function that emits certain events. So you'd be like, well, how do I check for these events? If I'm not listening, then I'll never know. So we're going to have to make some changes. So we have our sorting hat as we had before, but now we've injected a dependency for the event emitter, which we're going to be using to emit these events. And then we have some additional setup we need to do for saying, well, we want to listen for on the allocated house event and the failed to allocate house event. And then we've got a catch-all, which lets us do that. So here is the new place on head function where we pick a house, and then if they get put in a house, then we emit the event, and if it fails, we emit the failed to allocate house event. So how are we testing this? So here is one way of testing it, where we're not mocking any dependencies in. We're just going to use the event emitter as it comes. So here we have a nice thing called jest.fn, where it allows us to verify if a function was called. So we have we're setting up the listener. So we're saying sorting hat on allocate house, and we're injecting the callback, which is the mocked function. We're calling the function, and then we just verify that it was called with those parameters, and that works just fine. And I won't go through all the other houses, but they're the same. And then for the failed one, we're just listening to a different event, but with the same kind of structure, which makes writing these tests really easy. But there is an alternative to using jest.fn, and that is to have a local variable that just checks if it was called and what the event was. But yeah, you can do them. I tend to go for the first one because it's. I think you get a lot better messages when the test fails, because it'll say, oh, what is actually called with something else. So we've got another example. We have the goblet of fire. So we have our interface, which is the goblet of fire. We've got some functions in there, so we can add a name to the goblet, and we can remove a name. And we have some tests as well, which just check to see if it's working as we expect it to. So version 1. So we have our add name function. which adds names to the goblet, and we've got the remove one, which removes a random one using the math library that's built into JavaScript. So this version is, so if we've looked back at that, we've got a protected read-only names array, which means that if we subclass this, we can get access to that. So when we're writing tests, we can make a stub where we can access the inner state of this class, which means that when we write tests, we can get the names that are in that array. So we see goblet of fire get names should contain this thing if we add it in. And the same with the name, we can check if a name's been removed, which is really easy because it returns that name that was removed, and we can return that the names in that array have removed one of them if we remove a name, so it doesn't come out twice. Which is good. So there's advantages to this. One of the advantages is that it's really, really easy to implement. And we can reach in and look at the inner state of this class that we've created. The cons are we can access the inner workings of the class, which should technically be hidden. And because we're using the protected keyword, there's almost an indication that a developer can subclass that for whatever reason. So we might end up with a new goblet of fire that also adds a different name, or extends the name when you put the name in, which is fine, you can do, but it wasn't designed to do that. Goblet of Fire v2. This is pretty much the same, but now we have a function at the bottom where, again, we can access the internal state. So this is different because it's using the Goblet of Fire class. Tests are pretty much the same, apart from instead of get names, which we had before, on the stub we have __ get names, which is a public function on that class. And again, with removing, it's pretty much the same, just with __ get names. So pros, very similar to the first one. Major con is just these things being littered around everywhere. Where if you work on a brownfield project that doesn't have any tests and you want to add tests, this is probably a good reason to do this before adding any refactoring to make it cleaner. But you tend to want to avoid these kind of things because even though it's marked as internal with this huge comment, there are some people that would go, it's just a comment, I'll use it, it's fine. So yeah, that thing there, just forget about that. Version 3. So this is about adding some predictability into it. So this is how it should look. So we have our usual like math.random, but now we can add some predictability by spying on that random function in math, so it returns a value that we know, so it doesn't end up being random. It's something that we actually know. So when we're doing the remove name, we know exactly what name is going to be removed from that names array. And yeah, so if we remove multiple names, we can set it multiple times to get different results, and it's pretty cool. Still some thinking involved in that. It's a bit weird because you've still got to use 0.0 something, so there's still a bit of cognitive load in there. So to make it better, we're going to be injecting randomness into it. So we've got our new constructor, which is a random number generator. And if you want to have a look what's inside that, it is a function that just does what we did before, with a slight difference that we have a min and max, so if we want to turn from 5 to 10, it could do that. Very simple, very simple. So we have our random generator, and in the remove name, we can call that to get a number to remove that from the array. So yeah, we've got that thing there. So what does this mean? It means that when we create our test, we can use this jest.mock function, which means that when we create a new instance of the random number generator, it will instantly be a mocked instance of that class. And with that mocked instance, we can inject that into the goblet of fire so we can make things a bit more predictable. So this is very similar to what we saw with the math.random spy, except here now we've got jest.mocked, and we can say what method we want to mock and what return value we want. So here we're just saying get me number 1, which ends up being index 1 of the array, which ends up being Ron Weasley. And we can do that again, get more predictable. You can pretty much understand more about what it's doing. So here we're just getting 1, which is Ron, and 0, which is Harry, and 0 again, which is the last name, which ends up being Hermione. And there are times when you don't need that mock, despite it being injected in. So you can call the mock clear, which just removes that mock entirely and tries to use the actual implementation. So yeah, it adds predictability. It's really easy to implement, and it follows a nice design pattern, which I'm sure a lot of you are familiar with. So one of the cons is you've got to write more code, which is fine because we're paid to write code, so we'll write more code. And another thing is that you will have to wrap some functions that are normally available globally, just so you've got things that you can use with descriptive names that you know what the function is going to do. So that was all the examples. All right, let's go for one more. So this time it's going to be all about spell casting. So here we have a simple class where we inject a wizard and a spell, and then we can cast that spell. So the wizard is a class that just has a name and the level of what they're at. And then we have a spell, which has the utterance, so how you say it, and what level is required to cast that spell, and a cast function that we can execute. So here we have a test where we're saying they should be able to cast it if they're powerful enough, or they shouldn't be able to, or throw an error if they're not powerful enough to cast the spell. Very simple tests, very easy to read and understand. So here we are, V1. So here we have the implementation. So if the wizard's level is less than the level required, then we'll throw an exception. Otherwise, we will cast the spell. So here we are for the test. I've injected some spells. And when we use those spells, we'll create a new wizard, give it the level that's required for the spell, cast it, and everything's all good. Test passes. And if we try and do another spell but make the wizard's level 1 less than the level required to cast the spell, then that we can check that it rejects that promise with an error message. So yes, very, very easy, very simple. Nothing you can really argue with out there. And then V1, we have it's the same picture, so I don't really need to talk about that. So we're going to have no spells, or rather, we're going to have some fake spells. So we've still got our spell interface, which is good. And then we can use that when we're calling the constructor for the spellcaster, where we can just say, well, here's a new spell. We've not made any pre-made ones, it's just there. We also have a cast function that we can mock to say, well, that's going to return an unresolved value, so that's good. And we can call it, and it's the same as the other one. Still works. And we can again make it reject as well, which is good. And then we can also add another test for unexpected occasions when actually casting the spell throws an error. We can check that that promise rejects as well. So yeah. So these have been funky examples that may or may not replicate the real world in which most of you live in, but you can use some of these examples as an idea of when you're writing your own tests. So you'll be able to mock dependencies that are injected in. For example, if you're working with third-party APIs, you can even inject Axios into a constructor if you really wanted to, and just mock the response that you get back from an external service. So yeah, this has been my talk. Hopefully all the information in your head is helpful. So we've gone through some Jest, been through some mocking. We did a bit of stubbing with that testable goblet of fire, some testing strategies. And yeah, that's it. I'll make this GitHub repository public after this, so you can see all the code if that tickles your interest. That's it. Thank you. Any questions?
One over here. Hello.
Yep.
Quick question. Do you do anything different when you're testing with TypeScript, like an approach point of view compared to vanilla untyped JavaScript?
No. Okay. Do I do anything different if I'm just using vanilla JavaScript to TypeScript? I'm very OCD when it comes to tests, where I just like everything to be the same. So even if I don't have types, I like to know that what I'm putting into a test is what I know it is. There's no hidden stuff that's going to be plopped into it. Cool.
Brilliant.
Thank you.
Thank you very much, Stephen.
No problem.
Thank you very much for that, Stephen. If anyone has any more questions they'd like to ask him, I'm sure he'll be hanging around for a drink afterwards, so go find him and go ask away. We're going to have a break now for about 10 minutes, so there's food at the back. Go to the loo, grab a drink. We'll reconvene in about 10 minutes, so go enjoy yourself, guys. Thank you. speaker of the evening. So if you'd like to give a warm welcome and a round of applause to Tolly, the head of engineering practice at Cinch.
Thank you very much. Oh yeah, you can't see anything, it's true. Is it a good time to tell her that you're streaming this so everyone knows that that's happening now, the conference? So I guess thank you for having me. It's great to hear that we're having more events in Manchester. It's really, really exciting. I really like coming to meetups. I actually met my first Manchester recruiter at a meetup, and that was Ross, and that's where we started kind of organising the meetup that was before this one. And we learned a lot from each other, and in one of the meetups, particularly Ross learned the difference between Git and GitHub. And I think that's the kind of thing, that's exchange information that's useful to have. So first of all, I'd like to give a big round of applause, well, I'd like you guys to give a big round of applause to Ross for all the work that he put in. He was very emotional earlier, and I know because he's put a lot of work into this. So a big round of applause for Ross, please. Right. And with that, I'll get into the talk. Great talk by Stephen about testing. It's a great segue into this talk because testing is very relevant to observability. But before I get on, a quick intro. I'm Tolly, head of engineering practice at Cinch. At Cinch, we take engineering practices seriously because we think it's a competitive advantage. If you want to know a bit more about how we go about it, catch me later, or if you're still using Twitter with everything that's going on, I'm on Twitter with Apostolis09. And that's that. But a bit more context. I started out with maths and mathematical physics, so I literally didn't care how the world worked. I was happy with the rules of algebra and geometry. And then I got a job in software and pretended to be a developer for a while. And that's where I learned that it's really hard to change the way you think. And but it got easier. I learned how to do this. I got comfortable. I was writing code and I was shipping software. But then I started working in more B2C industries and things started breaking, production broke, and then I got really stressed and I got all the anxiety that a lot of developers have. And then that's when I started getting into observability and reading about it, learning about it, and got the chance to implement it at Cinch. And the big question is, why do they call me Tolly with two ones and a Y? So you might hear, has anyone, actually, I can't really see you, but put your hand up or scream if you've heard the term observability before. Yes. Good. Observability is often abbreviated as OLLI, and OLLI is a numeronym. You take the characters between the first character and the last character, you count them. I actually counted them yesterday because I wasn't quite sure whether it is 11, but if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, you use the numbers twice, and then you have OLLI. So you don't want to keep saying observability all the time. Anyway, the same thing is with accessibility, which is also ALI. So that's what OLLI is. And then you take Tolly and OLLI and you make it Tolly. And the reason why I'm saying this is because when I started at Cinch, I kept saying, well, what about observability? I know you're writing all this code, but what about observability? You're writing this code, you're testing this code, you're sending it to production. How do you know it's going to work? Have you seen the spike in Datadog or whatever observability tool you use? And I said this over and over again as a broken record. And that's kind of how you get the nickname. There's at least one Greek person who might understand this here. We have a saying in Greece that it's better that you lose your eye than you get a bad nickname. But in this case, it actually works out well because you achieve something. So why am I here? So this is a bit of a big one, and probably don't know if you can see it. I've got this thesis that the more observable your systems, the more democratized your understanding of the systems are across the company. So keep this thesis in mind as we go along. And this talk is about observability. But if you want to read a bit more and learn a bit more, these are a few resources that you might be interested in. First of all, when we first started out with Bob there in at the front, there was no book about observability. There is now, and it's excellent, and I highly suggest reading it. If you're not into books and you're still into Twitter, as I said, follow Charity Majors. She's the co-founder of Honeycomb. She's got loads of good things to say about Honeycomb and observability. Or read her blog, and that's some really good content in there. If you're not into books, there's a really good podcast, again, by Honeycomb, but really good episodes around observability. So that's where you can learn more. But there's a definition in the book which we can go with, which is you can understand any bizarre or novel state without needing to ship new code, then that's what observability is. And this works. Not shipping new code is the key thing here. And if I expand that a bit more, is observability is a state of the system. It's not something that you do. You don't do observability. It's something that you achieve. Your systems are observable. And as I said, you explain any bizarre or novel state. You can't see all that actually, without shipping any new code, but also without predicting any state when you're creating your telemetry data. And just to clear the air, you might say, well, this is another buzzword that we need to care about. I'm making the statement or the prediction that it's not a buzzword that's going to go away. So I'm trying, my mission is almost I want to persuade everyone that you need to take observability seriously. And I've got two things to back that up. First of all, who's heard of DORA metrics, or DORA or Accelerate, put your hand up. Okay, a few people. So in short, there's a kind of popular DevOps research that basically found that delivery predicts company success using these 4 metrics. And that kind of came out in 2018, and it's evolved over time, but it kind of means that, you know, if you're good at software delivery, then you're more likely to be successful as a company. But then, can't see that. But then lately, in the last 2 or 3 years, they're finding that it's not enough to deliver well. You also need to operate reliably too. So you've got this 5th metric, operational performance. And there's other things that go into reliability and operational performance, but observability is a big one. If you want to learn more about this, there's the Accelerate book. Highly recommend reading it, or get involved, or read the Accelerate State of DevOps reports, or there's a DORA community online that you can learn more. Second thing I'd say is that there's this great diagram by Emily Freeman, who's tried to kind of articulate the evolution of DevOps, because we've gone through a few years of incrementally getting better at DevOps, and she was saying that nowadays software engineers need to architect, they need to develop, they need to automate, they need to deploy, they need to operate, they need to do a lot of things. And to do all these things, they need to achieve all these ilities, if you like, these 6 ilities that go around the concentric circles, and one of them is observability, alongside securability, scalability, and things like that. So we do need it. So that's just to clear the air. So one of the reasons I'm here is because we established a culture of observability at Cinch, and I wanted to kind of tell the story, but also share a bit how we achieved it, and maybe you can learn from this. But it did take us 3 years to get to where we are now. So the question is, how can you establish a culture of observability if I persuaded you that you should? So there's 3 simple steps. You choose an observability tool, you enable the telemetry data, and you auto-generate the dashboard. Just can't see you all. Right, so, and then you're done. That's basically the three steps you need to go through. But unfortunately, it's not as easy as that. You can't buy yourself into observability. You can't, it's not something that you can just switch on. And this is where it becomes more of a zero to hero approach, or even if you're working for a company where you've tried things out but it's not quite worked, this still applies to you. If you take away 3 things from this talk, is that observability is about tooling, instrumentation, and mindset. And I think the reason why that's important is kind of like DevOps. DevOps is not only about buying a tool. You need to have the techniques, the patterns, and the mindset to be DevOps, if you like. And then to expand on that, there's 3 steps. You want to pick your observability tool, but critically let everyone have it. You want to instrument your code. I'll get to that in a bit. But you also want to support and enable learning. Start with picking observability tool. That's kind of your first step. All the rest is practices and learning. But your first step is you do need to choose a tool. So there are 3 classes of tools out there right now that you can choose for. You've got your traditional ones. It's really dangerous here. If I fall off. So you've got your traditional ones, which are your Datadogs and your Dynatraces. You've got your more contemporary ones, your Honeycombs or your Lightstep. Or third class is any class that's basically not specific to, is actually more specific, sorry. So in this case, we've chosen serverless because we're entirely serverless. And you've got Lumigo and Hexagon, and these are just examples. But they're different classes, and the reason why they're different, because you'll hear Datadog and Dynatrace talk about 3 pillars, traces, metrics, logs. You'll hear Honeycomb and Lightstep talk about events a lot. And you'll hear Lumigo and Hexagon talking a lot about serverless constructs and concepts and things like that. So although they're all observability tools, they take different approaches. So how do you choose? I thought I'd give you about 4 heuristics or questions that you can ask yourselves if you're looking to choose an observability tool. First, and step 0 almost, is can everyone use a service with no extra cost? So typically, observability tools their billing model is on telemetry data ingestion, so not on seats, so you can add as many people as you want to it. So that's kind of a given, but if not, I'm just putting it on there for completeness. Second question is, does the vendor have excellent DevX tooling? The first thing you want to do is get your developers on your side. To enable, to get a culture of observability, you want the developers to be advocating for it. So they need to have good tracers, good SDKs, all this kind of things. And then third question is, how far can you get without checking production? You want to get to a state where you're not checking your cloud production accounts. You're able to understand a lot by just checking your observability tool. And finally, I was reading a report this week around kind of the future observability vendors, and this came up a lot, the billing. So especially in this financial climate, it's really important that you're able to manage billing effectively. There's loads of ways to do this, but if you are looking for an observability tool, I'd question that first and see how easy that is to do. So that's with picking a tool, and I won't go into more detail of that. That's kind of your basic heuristics. The next thing is instrument code. But before I go there, I kind of want to do a bit of a bridge to Stephen's talk. Observability is very much like testability, because like observability is on this diagram, testability is down there. You guys probably can't see it. There's testability here. And testability is about the extent at which your software supports testing, because in any given context, but testing is important because you can find your faults because your testing is easier. And my second thesis of the day is observability is the testability of 2020s, but better. So we went through all the stuff that Stephen was talking about, your unit tests, your TDDs, or your testing after you've shipped to production, all this stuff. All these patterns, we've learned them over the years, we've got better at them, but we haven't done that with observability, but we are doing it now. So observability is not as mainstream. With observability, you go through a process of writing more tests so that you can change things quicker and safer, and that's basically what Stephen was talking about earlier. With observability, you instrument your code so you understand things quicker and better. So I'll take a quick segue so that I can explain instrumentation a bit. Kind of like unit tests, really. So instrumentation is the practice of systematically configuring your code to emit telemetry data. And you do that because you want to provide insights to how your code is exercised when it's in production. So whether you write tests or not, and it goes into production, you want to have systematically configured telemetry data so you can understand what happens in production. So an example that most of you will be familiar with is writing a log. An order was placed with order ID XYZ. But then what contemporary observability practices suggest is that this is not the best way to systematically configure. The suggestion is that you go through this add tag process where you add an order ID with XYZ, your user ID with ABC, and your order placed with true, because that makes it easier to query on the other side. That's just almost like an implementation detail of the instrumentation, but it's examples of where we are, and some good examples of this in the observability engineering book. And to illustrate this a bit more, you'll see this a lot. If you start looking into observability community, you'll see this level of awareness versus level of understanding. So in the top right, you'll see things we are aware of and understand, and those are the logs. You write your log, you know what you're looking at on the other side, and then on the bottom left, you've got your traces. I'm not going to detail what traces are here, but it's the things we aren't aware of and don't understand. That's what traces enable. They unlock this potential of understanding these things. So the one suggestion I'd give as guiding principle for observability is think of every input, output, or parameter in your code as an opportunity to learn. Take that opportunity and represent that as a data point in your telemetry data set. Because ultimately what you're doing is every point in your code is an opportunity to learn. You make that a data point by sending it to your observability tool, and you're constructing a telemetry data set so that you can answer any question. So that's probably your guiding principle of how to look at observability. And I'm not in competition with Stephen here with this statement. Basically, observability is a superset of testability. You need both, but my thesis is that you need observability more. Because if you think about it, testability enables rigorous lab testing. So the promise statement is, I promise that I will change the software and it won't get any worse. If anything, it will get better. That's the promise you make with testing. With observability, you enable widespread field testing. So what I mean by that is that you promise you'll have a service and you can rely on me. That's reliability. If I make a change, I promise that the service will get better, and I will know if it doesn't. That's the statement you're making. And almost if you've got your instrumentation well, you can get more confidence of changing things quicker and safer as well. That's what I mean with observability and testability and their relationship. So having gone through this process over the years of getting better at testing, integration tests, unit tests, end-to-end tests, TDD, we're now at a point in time where we can think about curating our telemetry data better to enable observability. And we've experienced that, so that's why I'm able to stand here and kind of tell the story. And there's another numeronym, interestingly, that you won't probably see much because I don't know how to pronounce it, but it's still a numeronym. And testability enables these known knowns, whereas observability unlocks these unknown unknowns. So a contemporary software engineer, contemporary product engineering team should be thinking about writing their code, writing the tests, and instrument their code for observability. It's not enough to just write your code. It's not enough to just write your code and write a test. You also should be instrumenting for observability. So those two things, you picked your tool, you've instrumented your code, and now there's the last bit of supporting and enable learning. So instrumentation and your observability tool is not enough. You can't just have those two. I saw a really good definition of observability in one of our recent podcasts of of Hacking the Org from Adrian Cockcroft. Who basically said that observability is where you can construct the behavior of a system by just examining the externally visible components. So what that means is that you have a black box that emits some really, really useful information, and then you can actually predict the behavior of the system in production by just utilizing this information. But you can't just do that. You need to make sense of this information. That's the statement that he made in the podcast that I really could relate to. So the question then becomes, well, you've got all this telemetry data. How can your teams make sense of it? And this is my other main takeaway, that we need to understand that it's not just about paying for a tool and instrumenting our code. We need to also make sense of the telemetry. So what I've observed, and my suggestion would be three things: support, learn and improve, but critically practice. So step 0, again, is you might have a golden path, a paved road, whether you're very explicit with that or not, but observability should be there amongst your TDDs or however you approach testing, event-driven, serverless, any architectural paradigm you're following. It should be there. You also need to enable software engineers to learn how to do these things, because it's not something that people know how to do when you recruit. So we did it by planting enablers into teams. These people here were software engineers whose job was to enable the rest of the team to get better at everything in the software lifecycle, from infrastructure as code, CI/CD, observability, SRE, all this stuff. This is one of the biggest things I've learned from the last 3 years, is that communities are very powerful. So think about guilds, think about any group of people that learn together. That's what I call communities. And we have a observability community with a mission to make observability accessible to everyone. That's really, really important to learn. And then you've got your more traditional stuff, your workshops, whether they're custom internal workshops or external ones from your observability provider. You have code exemplars of how to instrument code up here. Or you're learning from instant reviews. So when things break, what can you do better with observability? And finally, practice. So you need to be able to practice these things. So this Chaos Monkey has injected 3 incidents to this team, and the team has had to respond to it. And as a result, they've learned where the gaps are in observability. So to summarize, pick an observability tool and let everyone have it, instrument your code, and support and enable learning. Those are kind of like the 3 ideas. You might ask, what can possibly go wrong? Well, there's some obvious signs that I've seen of things not going quite well. First thing is that there's one person, and it's typically in ops and dev setups, one person who knows everything about observability, but actually no one else understands the dashboards or anything. A third thing that is quite interesting is that in the past it's probably okay to just have infrastructure level metrics like your 400s, your 500s, things that are kind of infrastructure specific, but you need to start thinking, if you see a lot of this, then you're not thinking about business level metrics, your orders, your sales, things like that. And finally, you might get an alarm that tells you what's wrong, but you don't know, you're not able to find out quickly why, and that's another signal, something not going quite well. But when do you know that you've made it? So there's 3 things on at 3 levels. I would say at the team level, observability, I think this is the reason why I'm here and able to tell you about this, because observability became a team responsibility. It's not my responsibility, it's not one person, it's a team responsibility. As an individual, practicing observability becomes a core skill, and at an organizational level, all teams practice observability-driven development, and they're continuously improving. Critical question, so what? So who cares? Because observability can be quite expensive. At Sinch, we're entirely serverless, so actually running our software is cheaper than understanding or observing our software. Our Datadog bill is more expensive than our AWS bill. So it is expensive, but there's 2 key benefits for me. One, incidents are rare. Teams have taken ownership of their software. They build, ship, and support their software, and their mean time to recover is low. All the indicators that show reliability are there. But then critically, our eyes are on production. We're not looking at non-production environments, we're looking at telemetry data that come out of our production systems. And that's basically our biggest win, with everything, all the consequences that good consequences that has. But this will not happen overnight, so I'll quickly go through what it looked like our last 3 years. Year 1, you will see, once you give them the responsibility, you will see the teams instrumenting their code, taking ownership of their alarms, and knowing how good their business transactions are looking like. Dashboards, then you see them owning and evolving. You see them reviewing them at stand-ups or stand-downs at the end of the day. And this is one of my favorite dashboards, the Order Squad's motherboard. And they review it at stand-ups and stand-downs. Are orders looking healthy? Do we have any incidents? Are we seeing errors? What changes have been released? And finally, in the first year, you'll see things like having a rhythm of observability improvement katas, improve observability via Insta reviews, and one thing that surprised me is that non-techies started to look at these same dashboards. It's not only a techie thing. The second year, you see a bit more advanced instrumentation. I won't go through this. But you also see other parts of the system like CSD and security being instrumented. You see service level objectives start appearing and observability communities start to emerge as well, as I suggested earlier. Third year, you start seeing these kind of code exemplars for observability, a more mature observability community, and subject matter experts emerge from software engineers. And then engineers become skilled observability practitioners. Almost everyone does. Non-techies know about observability, more about observability than they know about testability, because they can relate to it. They can see the thing. They can look at the dashboards. And all teams consider, and this is the real win, all teams consider observability as a given, like they do with tests. So the big question that I posed at the start was, how is observability? I think observability is democratized, this big statement that I made earlier. That the more observable our systems, the more democratized our understanding of our systems are across the organization. And what I'm starting to notice, I'm not saying this is necessarily happening, that observability is eating the worlds of business analytics and data intelligence. And observability is blurring the lines a little bit. Because if you ask yourself, is observability a dev thing? And while preparing this talk, I came across this wonderful workshop that was built by BAs for BAs. And it was about observability. And I had evidence that it's not only devs that look into observability, it's actually for, not only for technical people. And I think the reason why that's happening is because understanding the software is only as good as your telemetry data. So if you think about how we've been creating our telemetry data over the past few years, is that software engineers are the curators of the telemetry data. So we'll ask, can you implement an SDK? Can you put Google Analytics in there? And then the business analysts will be the consumers of that data. What's happening now is that these things are merging a bit more. So software engineers are both the curators and the consumers of the telemetry data, and the business analysts are benefiting from that as well, just like we did with DevOps. But I'm not going to come up with a new acronym for DevOps, so I won't go there. But devs have taken ownership of the quality of the telemetry data, and they support it. That's what I've seen. This is an example. So when we released multiple card payments, when you buy a car, you might want to use more than one card because there might be limits in a single card. The team that released the software team that released this was monitoring how many users are using multiple cards versus how many users are using single cards. So this is, and then another one where we've got funnel conversion from find vehicle to checkout, model searches and makes for cars. And suddenly you're seeing a lot of customers, a lot of users, and these are the dev teams that are looking into these things. So to wrap up, I asked this question over and over again like a broken record. And then, how do you know your code is working in production? And then, as a result, with all the stuff that I talked about, 20 plus teams practicing observability. Observability is a superset of testability. These are the three steps you want to go through. Pick an observability tool, give everyone access to it, instrument your code and support and enable learning. Have a look at this book to learn more. And in that book has an interesting statement that I can relate to. There's no one way of doing these things. So you need to think about what you want to achieve and make it work for you. Don't try and necessarily copy what I'm saying, but more or less, that's probably the journey you want to go through. Because the reason for that is because you will amplify and democratize the understanding of the behavior of your system. And that's invaluable if you're able to do that. You're able to understand what your software is doing and how customers are using it. And as a general statement, I think it's 2023. I think we do have a collective tech debt in the industry. We haven't taken observability seriously. Some things have matured, tooling has matured. We don't need to care about a lot of things that we used to care about with serverless and so on. And I think now we're fixing it. So my call to action is go back to your companies and try and see if you can implement some of these practices and try and implement this culture, because it is something that we should be thinking about in this decade. And that's it. Thanks very much. Yeah? Has anyone got any questions? I can't see you though, so I have to sit. Yes. Oh, hello.
Hi. You mentioned chaos days as part of your kind of observability practice.
Yes.
How do you kind of go about those?
So the question was chaos days, how do we go about those? We've gone through a journey. So initially we would self-organize for chaos days, and we would spend a whole day injecting faults into so someone would be the chaos monkey and the rest of the team would respond to that. So they would go along the day as if they were normally doing work. Then an incident would happen in the dev environment and they would have to go out and fix it. So there's probably about 2 or 3 incidents in a day. So if they solved an incident, they would go back to working. So it's more a practice in how you respond to incidents than to test your software, because in our case we're entirely serverless, so there's not really a server to take away, for example. So it's quite reliable. It's more about how you respond to incidents. Does that answer your question? Yeah. Cool. Anyone else? Yeah.
You guys are a startup, effectively, scaled up. Do you think this is, over 3 years, do you think it's been easier to achieve this from a standing start, say, retrospectively putting this culturally into a business that's already written the code?
Yeah, so the question was, we're a startup, so we were able, so assuming we were able to do it a lot easier because we started out greenfield, and whether you're able to do it if you've already got something. So first of all, we're a startup, but we weren't greenfield. We actually had some existing software, so we had to retrospectively add some observability there. Secondly, we released the first version of the website without really good observability, so we did retrospectively do it. So I think, yes, based on our experience, it is possible. And I think the other problem is that the industry is not ready for observability. You don't look at a CV and people talk about Datadog or Honeycomb or anything like that. They'll mention GitHub, they'll mention AWS and Azure, but they won't mention these things. So my plead almost to the community is go and put it in your CVs, go and learn about them so that all these things can be easier. One of the biggest problems was actually upskilling people and getting to understand collectively how to best approach it. So definitely it is possible, and I think we're just going to get better at it. It was a very good question. What's this? The last one here, by Paul Richards. Is it possible for observability to make life harder and confuse rather than boost understanding? Or is there anything better than nothing? And is it possible to tame it if there is tooling overload? Is it possible to make life harder and confuse rather than boost? Yes, absolutely. So you can completely get lost into all this telemetry data. That's part of the problem, that you need to make sense of it, and that's the missing thing that we haven't been talking about. The tech debt that we're solving is get the telemetry data in the tool. That's the first step, in a way that it's beneficial. We can unlock those unknown unknowns, but then the next one is how can we get better at understanding the data that we have. And the tools help with this a lot. That's why the first step is really important. So you can get overloaded, but that's part of the practice, I would say. Any other questions? Are we done? Yeah.
Time for one more.
Make the business embrace that capability culture, but did you face any pushbacks?
Yeah, absolutely. So you get a lot of, so the question was, in the journey, do you get any pushbacks? You do get pushbacks, like we did with testing. I think Stephen touched on it. Oh, why do we need the test? Just get the code out quickly. And you get the same type of pushbacks. You also get pushbacks for cost, because tests don't really cost. They cost in time, but observability does cost. So you do get pushback for that. But the way I always contextualize it, if you make at least one developer's time more effective, then you've covered a lot of the cost of the observability. One might be an overstatement, but you know what I mean. Developers are expensive, so make their life easier, and you'll achieve that. But yeah, it's a very good question as well. Thank you very much. I can see you from here, so it's a lot better experience. But yeah, thanks very much.
Thank you very much for that, Tolly. Just like with Stephen, if you have any more questions that come to mind, please go find him later on in the evening and ask away. We're going to go for a quick 5-minute break, so if everyone wants to go to the loo, grab a drink, whatever, please be seated in 5 minutes' time. Thank you very much. So, yeah. The final speaker of this evening, so last but certainly not least, I'm going to pass the mic over to Chris Grice, the Head of Engineering at Street Group.
Hello, Chris. Can you hear me okay now? Oh, it's on. Yeah. Hello. So, I'm here to talk about psychological safety. A bit of an intro first to why I care about this. So, oh, that's a very small slide all of a sudden. What's happened to my text on my slides? I'm hoping that's not that entire way through. So yeah, I'm Chris. I'm Head of Engineering at Street. I've been building things with software for about 15 years, which is a horrifying number. The last 7 of those, I've been building teams, scaling, building, kind of getting teams in place. So psychological safety is a large part of what I think makes teams successful. I think Tolly spoke about observability being like a buzzword before, and I think psychological safety has a similar reputation in a lot of places. It's seen as kind of a very new concept, but actually it's got a very long history. So I kind of want to talk about it a bit today and why I think it's so important. So first off, we're going to talk about what psychological safety is, where it came from, the research behind it, because there's a lot of research, how to recognize it, how to measure it, and finally what you can actually do about it to improve it in your teams. So this is the official definition that you can actually read, thank God, of psychological safety. It's the belief that you won't be punished or humiliated for speaking out and that you can take interpersonal risks at work. That is quite a mouthful. So what does that actually mean in practice? So psychological safety was, it's actually quite an old concept, but it was popularised by this lady, Amy Edmondson, who was a student at Harvard back in 1991, I think studying organisational design. I always forget the name of the course. And she was, in 1991, she was included into a research programme around medical mistakes. So going into hospitals, seeing why people had made mistakes, what mistakes they've made, how it happened. And she started to put together a research program to see if culture of teams had an impact on how mistakes are made. So she went to hospital, and there's quite a large variance in teams in hospitals. So she looked at 2 specific teams. Had an orthopedics team, which were really, really formal, very quiet, kind of very clear desks, clear stations, tidy desk, tidy mind, all that sort of mindset. Managers were wearing business suits. They made 1 mistake every 3 weeks. The cardiology department, which I'm not sure if you can see, opposite. Very chatty, very informal, picture the kids everywhere, messy desks, the nurse manager's wearing scrubs, 3-4 mistakes per week. So quite a large difference in both culture and outcomes. So she, as any good scientist does, made a hypothesis. The teams with a stronger culture and a stronger performance make fewer mistakes. So she went off into the hospital, sent some research assistants in there, measured mistakes, measured culture, looked at the cohesion of the teams, and of course, found the opposite. So the strongest teams from all the measures she made were actually making more and more mistakes. So of course, very scientifically, she went, what? What's going on? And spent a long time kind of trying to work out what had happened, and eventually found out, from looking at a lot more research, she asked this question of the team. If you make a mistake in this unit, is it held against you? And there was a massive correlation between teams that said no to that and who reported more mistakes. And that was the key kind of insight in her research, that it wasn't teams that are making more mistakes, stronger teams report more mistakes. And actually, stronger teams feel safe to make more mistakes and say, to tell people I've made a mistake. Examples made of nurses who'd noticed the wrong drug being given to a patient and gone, oh, well, last time I mentioned this, I got told off by the doctor, I'm not going to mention it this time, and actually caused a mistake. People assuming that the correct decision was made, or if they spoke out against it, they'd have interpersonal risk associated with that and consequences. So, that sat in research in Harvard for a while. She wrote a book about it called I can't remember the name of the book. She wrote a book about it, sorry, which sat, not unread, but kind of sat around for a while. Google back in 2013 did some more research into what made their teams more effective. So they looked at 180 different teams across business, sales, development, engineering, and looked at what made teams effective. So they looked at the reputation of a team inside the team. They looked at the reputation of a team from an executive point of view, a reputation of the team from the team lead's point of view, and the actual output of the team, so sales results, dev results. So they've really kind of rounded what makes a team effective. And asked a bunch of different questions, and again, found no patterns whatsoever, and a complete mess of data, loads of different things conflicting back and forth, and had a similar reaction and went, how do we parse this data? How do we go, this is what actually makes a difference? Someone came up against Amy Benson's research and went, aha, let's ask those questions. Let's look at the research she did and ask the same questions. And suddenly, there was a massive, massive correlation between teams that had a higher social safety and teams that were more effective by Google's own metrics. And it wasn't just a little bit more effective, it was double as impactful as any of the rest of these other things. So teams that had a higher social safety were way, way, way more likely to be effective. It wasn't the only thing. So they looked at dependability. Can you actually rely on your teammates to build good software and do it on time? Structural clarity. What's my job? Why am I here? What am I meant to do? Meaning, as in, is this work, do I actually care about it? Do I want to do this sort of thing? Impact, do I think it's actually making a difference to the wider world? These were the biggest 5 things that made teams impactful. And that's shown through lots and lots of research. What I've always found interesting is the things they found that weren't impactful. So these things, they didn't not matter, but they mattered much less. So whether you're sat next to your teammates, whether you have a bunch of extroverts, whether you have lots of really senior engineers, these things are interesting, but didn't actually make a difference how effective the team was. I think there is research around some of these other things, like team size definitely has some impact. It didn't show up in this research, but it has shown up in the research. The one that always gets me is the consensus-driven decision-making. So I used to be very much consensus-driven and want to do much more kind of collegiate decision-making stuff, but actually it doesn't make any difference to how it's successful as a team. If your team has that culture, fantastic. It doesn't mean it's going to be successful just because of that. I think Tolly mentioned as well the DOOR report as well. I think in 2019 they started bringing psychological safety into that report as well, and it showed in all the research that the teams that had a higher performance in the DOOR metrics also had really high psychological safety. So I just wanted to put this research together because it's not just a buzzword that people want to do, that all the research shows that psychological safety makes a massive difference to your teams. How do you actually tell whether you have it or not, I think is the biggest thing though. And I think there's ways to measure this, but the best way I like to look at it is by examples. So, who's heard of Anbon codes? Does anyone know about lean manufacturing or Tolly? Excellent. So Anbon code is a thing that was popularised by Toyota back in the 70s, I think. It's the idea that literally a physical cord on an assembly line making cars, where you can, if you notice a mistake with the car, you can pull it and it stops the entire production line. Back in the 70s, this is a revolutionary idea. It's a very expensive thing to stop an entire production line. You pull that cord, you are costing the company thousands of pounds per minute, probably more. And it stops everything. So obviously that's quite a risky thing to do. But they put a culture in Toyota as part of the lean kind of manufacturing process that says, actually, there's a process around how you do this. So if someone notices a mistake, they pull a cord. The very first thing you do is that someone who is monitoring this, the andon is the name of the lights that flash up when someone pulls the cord on this dashboard. The first thing they have to do is go to that person, not ring them, not send another person, go to the person that pulled the cord and say thank you for doing that. So you just cost the company thousands and thousands and thousands of pounds and saying thank you for doing that. And then how can I help you solve the problem? Not how can I solve it for you, not how can we fix this, how can you solve it and how can I help you do that? And it's this culture of it's safe to take risks, it's safe to go, yeah, we'll pull this. And it kind of ties into the quality argument where they would rather people take a risk and pull it to get quality and be safe to do that than have 200 cars go out that were terrible. So it's about a cultural kind of expectation that things are safe to do. A negative example, does anyone know who these people are? Oops, whoops. So, this is the crew of the Columbia Space Shuttle. They had a routine mission to go up to do some research, and on launch, after 80 seconds, a piece of debris hit the wing. So a piece of foam fell off and hit the wing. They didn't have great footage of it, so they kind of convened together a bunch of teams to go, okay, what's happened here? Is there a risk? The fantastically named debris assessment team was part of this and wanted to say, okay, has that actually impacted the wing in a dangerous way? They wanted to get some imagery. They wanted to ask the team, can we get some better photos of this? Were denied. Went through around the chain of command to ask other people. Were told, go ask your boss. The lead of that team wrote an email or drafted an email to senior management at NASA saying, look, there's a problem here. Management are stopping us from going after it, and then did not send that email because he was scared about the consequences. There was an all-hands meeting with all the people teams involved in doing this. Someone stood up and said there were no safety concerns, and not one person in the debris assessment team stood up and said, no, there is safety problems because they were scared of losing their jobs. On re-entry, the Columbia shuttle broke up and all 7 people died. It's a bit of a drastic example, and usually most things don't lead to 7 people dying on a space shuttle, but it shows the consequences of what happens when you don't have the safety to speak up and take risks. So yeah, sorry to go slightly heavy one, but I think that's the most impactful example you can show about why this stuff matters. One slightly less depressing example from recent experience. So I was working with a team who, a person who come into the team, was learning a lot of new stuff and realised there were a lot of areas in technology they were kind of not confident with. Rather than kind of sit and go, oh, I'm not sure about this, they put together a spreadsheet and said, here's all the things that I'm not sure about. Can anyone help me, please? Which I think is a really vulnerable thing to do. You're saying, here's the things I'm crap at. Can you help me, please? And some teams with low cycle safety might have gone, either not willing to do that or might have kind of taken that as I'm showing myself up as being unskilled. This team went, that's a great idea. We'll add our stuff on top of that as well. And now that's turned into a weekly or bi-weekly idea of like, okay, here's the things we're not sure about. Who can teach who can get involved, and everyone's getting better. So by taking that risk and taking that chance to show some vulnerability and being safe to do that, the team is getting better and better and better. So I think it's more useful to see examples. I think it's easier to see it, know it when you see it sometimes than measure this stuff. Social safety is not something, so it has a reputation as well of being about low accountability and kind of being able to get away with stuff. It's nice, safe, happy things to do. It's not about being nice. I mean, we probably should be nice anyway, but it's not about being nice for the sake of it. It's not about low standards. It's not about removing accountability from teams. Amy Emerson talks about this a little bit in a TED talk where she talks about this idea of if you have cycle of safety, it's not enough. You need accountability too. If you have no accountability, no cycle of safety, you kind of don't care, right? You're in the apathy zone. If you have really high cycle of safety, it's a very nice place to be, but you probably don't get that much done. It's a very comfortable place, but nothing really happens. If you have loads of accountability, but no safety, which I suspect many people have been in the situation more than others, you're in the anxiety zone where you don't feel safe, there's loads of pressure, not very pleasant. Where you want to be is high accountability, high social safety, and that's where learning happens. Because you can take risks as a high performance culture and you get better and better and better. So this is, if you want to go measure this in your own teams, this is the original survey that Amy used back in her research. I'm not going to go through it in detail, but it's the idea of like a Likert scale system where you ask people to agree or disagree with statements. Sorry, 1 second. I think these questions are really powerful, and it's what then Google used in their research to say, okay, let's use this to measure cycle safety. Do it with caution though. So, the people who answer this survey are more likely to feel safe. If you don't feel safe, you're not going to answer a survey from the company that says, do you feel safe at that moment? If this is going to be used for decision making, people are influenced to answer it a certain way. It's called Campbell's law. If you think it's going to be used as a kind of decision making, it's this incentivization there to kind of influence results. And if you don't take any action and just do the survey and just measure it, it actually has an adverse effect on psychological safety. Because people go, well, you asked us about this stuff and nothing happened. What's the point? We feel less safe to answer this in the future. So it has to be part of a wider program of actually measuring and improving this sort of stuff. If you just measure and do nothing else, it actually hurts. So how to improve apart from just measuring a survey and then doing nothing? It's important to know what the teams you're looking to improve and where the organisation is in terms of stages. So there's some more research done kind of recently around different stages of psychological safety. So inclusion safety is almost table stakes. Do I feel part of this team? Can I be myself? Am I excluded from the team? There's a threshold here that if you're below that, there's a more serious problem than psychological safety. Learning safety, am I able to ask questions, make mistakes, get better as a member of that team? It's contribution safety in terms of can I actually get involved, get stuck in without feeling like I'm getting knocked back? And challenger safety is where people mostly want to be, which is can I challenge the status quo, can I make suggestions, can I take bigger risks? If you have different people at different stages of this in your team, you can't jump straight to challenger, making sure everyone's happy to give ideas and suggestions and challenge status quo. If someone actually doesn't feel included in the team, or someone can't feel safe to learn, You have to build it up over time and build the levels of safety as a team and as an organisation. And it's quite similar to, if people heard of the Tuckman stages, or otherwise known as forming, storming, norming and performing. This is the idea that teams go through normal life cycles of stages of forming. So they kind of come together, they sometimes clash, they have differences of opinion, so there's a storming period where people have different ideas, and they kind of hash that out. And as you kind of get past that, you get into a bit of a normalisation phase where you go, okay, we know what we're doing, we know each other, how each other works, we can kind of get into this pattern of continuous improvement, and that improvement slowly gets to this performing stage when you're continuously learning, continuously improving. I think these two stages really mirror each other. There's a really clear thing: if you don't feel included, you can't form a team. If you don't feel like you can learn, you can't find out how each other works. So it's really important to know kind of what teams are like and how and what stage they're at when you're doing this stuff. Measurement, I did say beware, but it is really important. That baseline is really, really helpful. So, okay, here's where we are before you start a larger piece of work around safety. It has to be part of that larger piece, but you can't measure you can't improve what you can't measure. The single biggest thing that Amy Edmondson kind of suggests around this is that what we tend to do is knowledge work. Framing it as a learning problem and not an execution problem is the single biggest thing you can do. Its work is not about, are we doing this thing correctly? It's like, how can we learn to get better at this? She talks about if you have low interdependency and very clear work, you don't really need psychological safety, but there are very few jobs that don't have interdependent teams and some area of unknown. So if you have those two things, which I think is all software, you need this as a baseline. And it comes into things like retrospectives, post-mortems, like blameless culture, continuous improvement. It's looking at how to continually get better at what you do and having that culture within teams. Admitting mistakes and admitting them up front, kind of saying, I'm fallible, everyone's fallible, we all make mistakes, I might make mistakes, call me out on them when I do. Make it safe to be called out on when you make mistakes, as well as calling other people out. And model the right behaviours. So I always say to people, there's a massive superpower in asking really stupid questions, and I do it very often. If you can ask really dumb questions and feel safe doing that, you're modelling the fact it's okay to ask questions and ask things that might seem obvious to other people, and that's okay to do. If someone gives you feedback or someone challenges, respond to it in the right way. One kind of defensive reaction to feedback can set a team back ages. And ask for feedback, be open in how you want feedback. I think it's really important to say as well that this stuff is not just a leadership responsibility. Teams are responsible for their own safety in a lot of cases, and is responsible for all the things we talked around inclusion, around learning. If you want to improve it inside the team, you need leadership support, but it's not just leadership responsibility. So I've slightly back through that because we're running a bit late, but that's kind of the model around why it's important, the research behind it, what you can do to improve it, and hopefully you can take that away to your teams and both measure how you're currently feeling around psychological safety and make an impact to your teams. Thank you very much. Any questions? I can't see anyone, sorry. So, oh, hello, yes.
I guess one question is there anything that can be done like at the sort of forming stage of a team that can help improve psychological safety, you think?
I think so, yes. So one thing I've done in the past is when you do that forming stage, have a really clear discussion about team norms and say, okay, we've created a new team, what's our expectations? I've literally had a team before that have written it out on a massive piece of paper and all signed the bottom. It's almost like a shared agreement with each other, like here's how we're going to operate. Probably don't have to do that every time, but that idea of here's how we're agreeing to work with each other and having that conversation of, okay, a good team would be happy to ask questions and give feedback openly and all this sort of stuff, and having that discussion up front might lead to some storming, but you've got that upfront discussion around here's what our baseline norms are. That's worked really well for me in the past. It's hard to backport onto existing teams, but you can still kind of reset the teams and do that, like, okay, actually, let's chat about team norms. It's a really good retro, actually, to do, like, what are our expectations? Oh, yeah?
What would you recommend for when one individual in a team is not creating that psychological safety that the whole team is forming on?
So the question was what happens when one person is kind of violating those norms? So I think there's definitely situations where that's a conduct discussion with leadership and all that sort of stuff, and I think those have to go through normal lines. What you can do as the rest of the team is, I think, challenge that behaviour and openly speak up and say that's not acceptable, that's not what we need to do. That in itself is a risky thing to do. If that person has tenure, if that person has seniority and influence, that's even harder to do. So it's not an easy solution to do. I think that's why almost your question around existing teams and kind of building it from the start is a much easier thing to do. I think if you're trying to backport it onto an existing that has this culture, it's why setting it early is really important. It's a really hard question to answer, to be honest. I think generally it's all the stuff you do around any other conduct issues someone's been performing. You have to really clearly communicate it, you have to set expectations. But that's where it does take leadership to go, we think this is a priority, and we see it as important as performance, as output. If you're not providing that safe culture, if the org recognises that it's important, then they should be more amenable to taking action. Hope that answers your question.
Yeah.
Cool. Any more? I can't really see, sorry. So. Oh, smashing. I can't see that, 1 second. Yeah, sorry, my eyes are terrible.
How would you suggest someone who feels unsafe in a team tries to improve things in a team?
So the question is, I think very similar, like how do you improve things if you feel unsafe currently? I think the question probably depends on who you feel unsafe or what you feel safe about. If you feel unsafe with your, this is going to sound very glib, if you feel unsafe to bring up concerns, it might be better to be somewhere else. I think it's so fundamental to a team being successful that if you can't feel safe in that team, it's kind of that fundamental inclusion safety. That's a baseline expectation across any team. If you can't have that, it might be worth looking elsewhere. But in terms of if you have that safe relationship with your manager or if your safety with leadership or mentorship, I think that's the path I would normally take, is to go, okay, here's a situation, I want to improve things. How do we work with you to do that? It's a really hard thing to do from inside a team when the team is unsafe. You need leadership support to do it. Any other questions? Cool, thank you very much then.
Oh, nearly there.
So there's one more.
There we go. Thank you very much for that, Chris. Oh, we've got one more. One more.
So, one more.
On like the day-to-day, in the day-to-day environment, how do you maintain that accountability within the team without influencing the entire team?
That's a really interesting question actually. So how do you keep accountability up without lowering safety, basically?
Well, yeah.
Yeah, so I think they're not opposites, I don't think. I think the accountability is having high standards, but doing it in a way that you need the safety to enable the accountability, I would say. If you don't have it, it's hard to have the other. So if you have that initial kind of, that expectation on the team, you can have those conversations around performance and around standards, that then there is an expectation that PRs are a great example. In a safe team, if you see a PR that you think is incorrect or needs work, you can be really open and say, I don't think this is good, it should be in this way. In an unsafe team, you'll probably hedge and you go, you might want to do this differently, or you might say nothing at all to the class. So there's the safety enables the accountability. But if you just have safety and don't then work on the next bit, that's when you kind of fall into it. So again, backporting safety onto a team that is already low in it needs a lot of work and support elsewhere. But not sure that answers your question, but that's why I frame it.
Thank you very much, Chris. Thank you for that, Chris. Likewise with Stephen and Tolly as well. I'm sure Chris will be staying here for a drink afterwards. So if you want to go, if you have come up with any more questions and want to go find him, then by all means go find him upstairs and ask away. There's no question is a dumb question after all. So next up, we've only got a couple more things to go over. I know we've overran a little bit, so we'll only be here for about 5 more minutes. Next up, when you all got here, you were given a raffle number. So I'm just going to quickly draw them out. I'm going to draw 3 out at once, and if you could all just come to this sort of area, we'll hand you your prizes, and then that should be that. So we've got a number 90. Number 90, yeah, if you want to come round here, thank you very much. And number 1. And the number 37. You got a 37? Brilliant, brilliant. There we go, 3 in a row.
3 in a row.
Happy days. Okay, so we've got 2 more things to run over quickly. They won't take long, I promise, and then we can all go upstairs, sing some drinks, and have a good time. So next up, I'd like to give, if you could all give a warm welcome and a round of applause to the stage, Mr. Colin Fronchak.
Maybe I'll just hold this
Yeah.
Right. Anyone else freezing in here? Right, just a quick shout out. Christ, I can't see anything here. I've got a meetup event of my own at on the 27th of April, which is SocialCode times product, which if you work with any product managers, any product owners, heads of product, please invite them along. It's a quarterly event. I'm already planning further events, so if you know anyone that might be wanting to speak as well, let them know to get in touch with me. I'm on socials like everyone else and always putting stuff out there, so hopefully you'll all see it. So yeah, please share all that information with your product friends and business analysts as well, or anyone else that you know that might want to get into product. And one of the speakers at the next event is actually talking about that as a thing, so please share. Thank you very much, everyone.
So quickly, I think Ross got halfway through his speech, forgot the rest, and he wants to carry on, basically.
Yeah, the long and short of it, I got up here, got dead emotional, and left. So I just wanted to say something quickly. Again, thank you to everyone for building this over the last 4 years. But I just want to give a huge round of applause to Jake. He's taken this on and really worked his arse off to make something special here. So, but over the last couple of years, everyone here as a group, you've built this as a community. You've built something really special. I can see huge amounts of friendship groups forming. Please keep going. Please keep speaking. Please keep volunteering. Please keep getting involved. Work with Jake. He's going to make something absolutely incredible. It's been my honour to be part of this over the last few years, but the reality is you've got someone here who can absolutely lead you to having an incredible quality event. Please keep getting involved. This is the Manchester tech community. Let's face it, we're better than any other city in the world. So keep growing with it, keep running with it, and let's have a really special event. And that was all I forgot to say. But cheers. Right, let's go for a pint upstairs.
Thank you very much for your kind words, Ross, and that's a wrap. Thank you all very much for coming to the first Manchester SocialCode of 2023, and I look forward to having a few drinks with you upstairs. Thank you and good night.